On the other side of internal rate of return is the net present value. This is the current value of all expected future benefits. This accounts for all ongoing benefits as well as any costs that might be incurred, with the time value of money also being taken into account. So, just because we're going to make $50,000 a year over the next 5 years on a project, for example, doesn't really mean we're going to make $250,000, because you have to take into account the time value of that money. Inflation gets in the way, the fact that we can't invest the money we will make in year 4 until we get to year 4, and so on, all mean that there needs to be a discounted rate applied to those future earnings so that we can better understand what that's worth to us today. So long as the net present value is greater than 0, it's considered beneficial. However, we might have a higher hurdle than that must be cleared based on organizational policies or on the comparisons we do with other alternatives when considering NPV. NPV is calculated using the same formula as IRR, with the summation of the net period cash flow divided by 1 plus R to the power of T, all of that less the initial investment. R here is the interest rate, while T is the number of time periods. And in this case, we have the other information to plug in, such as the cash flows and the interest rate, but we don't yet know what the net present value of all of these different factors is. Financial calculators and Excel are both also helpful in calculating NPV due to the complications of its formula and the types of cash flows that can vary from year to year. Let's look at a couple different examples. In Solution A, we have a $50,000 investment that takes place that offers a $25,000 benefit per year for 3 years with an ending value of $0. Let's say that we're in a 5% interest rate environment because that's the rate at which we can borrow money in order to fund this investment. Here, we would expect a net present value of $68,081 with 20 cents. That's based on the $25,000 per year in cash flows, $75,000 in total. But we're applying that 5% interest rate to the money that we're not going to see until the ends of years 1, 2, and 3 based on an investment that we make today. Solution B indicates a $75,000 investment that has a $20,000 benefit per year for a 5-year time span. Again, we have a $0 ending value, but our interest rate is a bit higher because the investment is larger and we'd have to borrow more money. Even so, we see that the net present value of this investment is higher at more than $84,000 due to the greater payback period over the span of 5 years instead of 3. As such, so long as we can afford it, we should probably move ahead with Solution B, even though it means borrowing more money.